The brothers Wisp. The brothers Wisp, brothers Wisp. The brothers Wisp. The brothers.
You're now listening to Greg. It's the Brothers Wisp.
Hey everybody, this is Greg with the Brothers Wisp number 87. I'm here in Texas still. I haven't left you guys. We went to the mom, we're back. And today we've got with us, for at least a minute, freshly shorn, we've got Tomas from Arkansas.
Hello everyone, and yes, I am currently in Little Rock, Arkansas.
Yeah, tell by the accent, it's obvious. And then, special treat, I don't know why he's here, but we always enjoy it when he is. We have TOM SMYTH. Where are you from, Tom, again?
I'm from Ireland, best country in the world. Booyah.
Yeah, I'll just leave that there.
You gotta let it sit there. That's for all the Americans there.
We'll let it marinate.
Yeah.
All right, Mikey, where are you at?
Brexit sucks.
I'm by Chicago.
Chicagoland. And then we've got Wilson. Where you at, brother?
Indiana.
Indiana. You sound so excited about that.
No one's excited to be in Indiana.
Other than the movie Hoosiers.
Corn.
All right. Sweet action.
The 500. We got the 500 coming up.
There you go.
So
You got a
that's a big deal.
All right. Let's do the quick thing. New patrons. For everybody listening, we have a patron account. It's patreon.com/TheBrothersWISP. New ones are Aaron Andrus, Mike Whelan, Alistair McLeod, and Doug Eames. I think those were all easy names to read. So thank you guys for joining in. And they are all officially Little Brothers, so they're in the private Slack. Little Brothers with Slack. So Thomas has to jet here in a second. Excuse me. He doesn't know what to do with himself because his timetables are flipped, so he's actually in the right time zone now, even though he's awake like normal. So he's going to tell us about the Confluence RCE.
Yeah, so super painful. There is an RCE vulnerability in Confluence, which is a wiki solution from Atlassian, which a lot of people use. So if you have a public Confluence instance, this is not Confluence Cloud, this would be your own Confluence instance. Better check that server. They've been installing crypto mining and all kinds of stupid stuff through the vulnerability. It's been announced about 2 weeks ago, and the really stupid part is that Atlassian decided to release fixes only for the latest version 6 of Confluence, which means if you are running version 5 or version 4 or even older of Confluence, which many people are, you are basically screwed. On top of that, the migration guide from Confluence 4 or 5 to 6 is like ridiculous. So, yeah, just good luck to anyone running public Confluence instances right now. That's all I can say.
So usually it's a wiki thing?
Yeah.
It sounds like everybody's pretty much just screwed.
Yeah, it's actually, so it hit even us. So our wikis that we maintain, we have 2 public wikis that we maintain, and both of them got hit. And yeah, so there is like a mitigation guide on, I think there is an official like security advisory from Atlassian. There is a mitigation guide in there. You can turn on some plugins and widgets, and that will also make you safe. But if you are actually using content generated by those plugins and widgets in your wiki pages, then of course that will not work. So it's a quite a bad situation. I really wish Atlassian would just do a little extra work and backport the fixes to at least v5 of Confluence, but that's just not what happened. So yeah.
I guess this is a migration path for them. This is going to encourage everyone to upgrade to the newest release. Is that the idea?
Which is, of course, paid, because you have to pay for upgrades for Confluence. So, yeah.
Yeah. Well, I mean, I from a developer's perspective, I'm sure you can understand they don't want to maintain a lot of old versions and have to do porting and stuff like that, right?
I understand that, but backporting, it's not like it's a super, like the vulnerability is not in the core of Confluence itself, it's in multiple plugins and widgets that Confluence uses. And those are not, super special, so they could easily backport those fixes to the older versions. They just decided not to. I'm sure there are reasons, and now everybody else has to deal with it.
Interesting. So something else I saw that you might have some input on before you get off is WPA3 has a new set of vulnerabilities that have just been, they're calling it Dragon Blood vulnerabilities that have been disclosed. I didn't even realize WPA3 was out in the wild yet, really, on hardware. I guess it must be.
It is not yet because it has not been fully standardized and disclosed yet. So currently it is behind a paywall, so only vendors and organizations that pay get access to the full WPA3 spec. And so it is not currently like out public released yet. It's work in progress, and already there are being vulnerabilities found, which is from one side of course good because those can get fixed before it is widely rolled out. On the other side, having vulnerabilities found in a security standard which has not even been released yet is well, it's a little sad.
Problematic. Is that the word we'd like to use?
At least it gets fixed before it gets rolled out.
For sure. All right. For anybody interested on a thing that you can't actually use yet, go take a look. So I guess it doesn't actually impact anybody. Not yet. All right. So a little bit of follow-up from the mum. I don't know if we said this or not yet. It was kind of a blur. The GPEN stuff never really made sense to me. You know the little repeaters? So for their... it's like their GPON alternative, right? MikroTik's copper stuff. They made these little couplers, right, that can extend the distance. I think that little dude's Jeepers? Is that what they call those things? The Jeepers?
Yeah.
Yeah, so they're basically like, they look like RJ45 couplers, and I was curious how you were going to use those things because there was no weather protection, and they said that they actually do have weatherproof enclosures. They just didn't have the graphics for them. Which I thought was funny that they didn't even mention that they existed either. That would have been nice. So it makes a lot more sense. They have weatherproof enclosures. You can direct vary and all that good stuff. Also, on that version 7 stuff we were looking at, that's actually an internal only alpha build. When it says beta, that doesn't mean like a public sort of beta thing. You guys have any other quick follow-up? I want to try and squeeze this stuff in before Thomas gets out of here. Do you guys have any other follow-up from the mum that you had thought about but we hadn't mentioned before? Wow.
Crickets.
Crickets.
No.
Right. America first, as Tom always says up there. So it makes sense.
Every second counts.
I actually had more fun at this one, I think, than I've had in a really long time. Probably because I didn't have to actually fly and all that stuff. It made it a lot simpler. But it was also in my backyard, and I love Austin. And we had a lot of fun. Gus's Chicken was a good time. I think, yeah, Wilson's preaching the Gus's gospel for sure. I think David, didn't you, like as soon as you got back, you found the Gus's in Long Beach?
Yeah, apparently there's 3 in LA, and just so you guys that don't know, Long Beach is part of LA, and funny enough, I drive past it every single day on the way to work. Had no idea. Had to go to Austin to find that one out. Pretty good. Service is slow, but it's good chicken. So, you know, I'm not complaining.
All right, and then on Friday we went to Master Pancake Theater. What was your impression of that, guys?
I loved it. I thought it was absolutely great because that's like me in a movie theater. I'm just blurting out shit, making fun of all the stupidities, and you know, and who better to make fun of than what the hell's his name? what was that guy?
Mel Gibson, is that who you're talking about?
Mel Gibson, yeah. Who better to make fun of than him?
It was Braveheart, and so it was basically Mystery Science Theater 3000 for adults, and it's very hilarious. It was a good time. Good time had by all. All right, let's jump into some of the Slack stuff. And of course, Tom already knew this because he casually mentioned it after I'd struggled for a while, but ESXi, if you want to pass all VLANs to the VM, you can set the port group to have VLAN 4095, and that's supposedly this magical signal to ESXi to pass all VLANs. And I didn't know that until I did a whole bunch of Googling after I was aggravated about it. So thanks everyone that knew it and didn't bother telling me. Of course I didn't ask, so I mean that could be problematic too. You're supposed to anticipate my needs, guys. You're supposed to understand my every want, Tom.
You sound like my wife.
I didn't realize your wife had such a deep voice, but congratulations.
Or such a bald head.
I didn't say anything about look like her. You said sound like her, so there you go. Let's see.
Well, actually, on that, I think we actually did talk about that like a year ago. You just weren't paying attention.
I don't know,
Yeah,
man. Sometimes you
ESXi.
guys have you go so far down the rabbit hole, I have to start skipping ahead. It's like, man, I can't read all this stuff. So I blame you guys. See, it's never my fault. It's always you. It's not me. It's you.
You also think now you sound like my wife.
All right. So let's see what else. Edwin was asking about spacing access points in a public Wi-Fi setting. The first thing that popped in my head was instead of worrying about signal carrying, like spacing in between, probably look at client density, right? Because a single access point can really only handle so many. If you're trying to put 2,000 people, on a single AP, you're probably going to have problems. What other recommendations would you guys have about spacing that stuff out?
Didn't Ubiquiti do that with one of their radios? They have like multiple radios inside of their radio so it can handle more clients?
No, I think that was Exhibit. He made that one. Hey, dog, we heard you like radios, so we put some radios in your radio.
Nice.
Routers.
But as regards BGP,
You heard about Router OS 7, huh? Speaking of BGP? You getting sticky?
I heard about that in 2016. I think was at the Miami MoMA, or else it was in the MoMA in...
2014 was Pittsburgh. They had it there. Well, the not a demo, but the performance specs.
But it was never leaked. Now we actually have a leak, so you can actually see what one core being used per peer.
No, root leaks were quite common with MikroTik, I think.
Oh, you're such a...
The hell? Kernek
You're an
left
animal.
us?
You're an animal. Yeah, he had to bust out.
Oh, man.
Let's see.
You were talking about wireless.
No, it's just more on the root filters. That's a frustrating thing. That, it's more...
From what I understand where they're at, and I might be speaking out of school, but they were concentrating on the route engine. You could see they're making progress on that. I think something like OSPF is done, but V3 is not done, and I think they still have to build the route filter portion. And there's still a good ways to go, but it sounds like the underlying engine's there. They just got to start bolting all the rest of the car together on top of it. So
why wouldn't they just use
something off the shelf?
Something like openBGPd they're actually been getting finance for RIPE to make the code more portable so that you can just run openBGPd on whatever you want. I think that would be probably more it might be more useful to use better quality code, and that's not disparaging on MikroTik per se, but if you were working on really ancient versions of Quagga or Zebra, they had their problems, they're well documented, the problems that they've had, the issues where you'd be so busy processing updates that you'd forget to keep managing the keep alive messages and sending them out. And if you're doing that on a very busy route reflector, then effectively you're going to start dropping sessions all over the place, and then that obviously then kicks off even more workload for the router when you're trying to restart BGP sessions and then learn the updates, and so it can create a vicious circle or a tailspin for your router. So it makes sense, I think, if they use a quality code base. That said, when I've moved to openBSD and Arista, you do miss features that MikroTik have, but when your entire customer base are dependent on it, the feature set has to work as advertised. And that's where I would say, being honest, that's where I think MikroTik need to just work better on, is that, less features, but more reliable, particularly that type of mission critical stuff. And I don't think I'm being unfair. Just maybe I'm less tolerant of failure than others, but it's it's just it's certainly a thing that I think they need to work better on. Maybe they are.
I think
maybe that's the reason why.
I think that's absolutely fair. I think that's absolutely fair. You know, there's certain scenarios where I don't think it necessarily makes sense to use it. Like, say you've got a network where you've got an SLA of 100% or something like that, right? You're probably going to go with something chassis-based, something that's got a couple of procs, something that's got multiple line cards, right? Multiple power supplies. Not to say that some of their kit doesn't have multiple power options, right? But that way, I mean, Cisco, Juniper, you could do in-service software updates where you update one supervisor, fail over to the second, update that one, right? So it's basically hitless upgrades. Also, and I've had my chassis before lose a supervisor. It completely tanks, and nobody ever knows it, right? And the upgrade path for us is to pull
hopefully
one out.
you know it, because then you can fix it.
I mean, customer-wise, nobody's yeah. I get the alerts on the failed supervisor, but customer doesn't see it. Replacement, you go into a window, you pull the old one out, you slam a new one in, you know, it pulls the configuration over, and you're back in business, you know, fully redundant. So, yeah, I 100% get there's usually the right tool for the job in various scenarios, right? So, no one vendor has the right solution for everything, and you know, it's so funny. We were talking at the MUM. We went into this big discussion about using VPLS tunnels to pull all of your customers back from towers, and then somebody else was saying, well, we use PPPoE right at the tower, right? And to their points, both very big, well-run networks, very successful, right? There's a lot of different ways to do it. You figure out what works for you, right?
Yeah.
No, I think in that scenario, there's one right way.
Oh, Dave.
But anyway.
Oh, Dave.
I'm not kidding. I'm pretty serious about that.
Now, that said, like, to be honest, I still use MikroTik for, you know, access points, CPs. Not so much on Wi-Fi access points anymore. But generally, you know, where they have been performing reasonably well. I do like the 1100 AHX4s. I think they're pretty nice. Back to
what you were saying earlier about you know, you just, you know, doing some work to use the you know, open BGPd on MikroTik. You know, they did have some, you know, route filter stability issues that, you know, they being MikroTik had to work out. But they also had performance issues to work out with the CCR. And openBGP is not historically known for performance at dealing.
I would agree with you.
Not in the forwarding performance, but in the control plane performance.
Yeah, in the control plane performance. That said, if I was to run it on the CHR versus like with the CHR versus, let's say, so running on the same x86 boxes, I found that with the 400 filters that I had, the equivalent rule set in openBGPd was faster. And also, it's important that the control plane aspects of openBGPd, where people were critical of it, were when they were running around 650,000 prefix filters.
Jeez.
So, and the problem with that was, so you'd have filter rules of 350,000 or 650,000, and then each update would be filtered by, there wasn't an optimization where, you know, irrelevant filters weren't being, or were being skipped, so they weren't skipping irrelevant filters. So each update, so if you're doing a full table, that's you know, 700,000 prefixes going through 650,000 filters. So that was pretty. That meant that convergence times were quite difficult and challenging. That said, Claudio in the openBGPd and openBSD development team got funded for a year to kind of tidy that type of stuff up. and also the filtering syntax is a lot more tidy, and so I think it's kind of a case where they're aggregating the types of filters, so it's like, okay, it's for this particular neighbor, all that type of stuff, but it's far better like that. I think they're going from, let's say, a 35-minute convergence on that type of configuration to something like 30-second convergence. So I think Job Schneider's also has given good talks at the various NOGs in 2018, late 2018, with updates about that. Another useful thing that they've done with openBGPd, which I think some of the vendors are starting to push out, is it's an RFC that was released where BGP by default is open. So whatever you learn on your router from an eBGP peer will be advertised to another eBGP peer if you have no root filters on. Mm-hmm. And so they're changing the default to be, instead of default open, default drop. So you have to specifically allow it to try and control the manifestation of root leaks and stuff like that on the internet. And it makes sense, because what's the first thing we all do when we were taught by good teachers on MikroTik was like, look, put in a default drop rule, don't advertise out, so at least all else fails, you're not actually leaking, or becoming a transit provider, accidental or otherwise, for people. So I think there's a lot of lessons to be learned from openBSD and openBGPd communities.
It's interesting you say that implicit deny. That's a default on iOS XR, the Cisco code. So if you have a peer in there with no filters and you do show IP BGP summary on there, it'll give you a little flag next to that peer and say, hey, this guy has no filters set, so we're not going to actually advertise any routes to this cat. So that was kind of cool.
Yeah, no, I think that's relatively new. I think that might have been in the last 1 or 2 years, I think. Now, maybe I'm wrong on that, but I don't know when that RFC came out, and I don't even know the number. There's just too many RFCs. So, but it's something that it was Job Schneider's talk. I'll try and maybe give you a link for afterwards that you can put in the video intro. But
so what are you using for BGP routers on your network, like to your exchanges and your upstreams and all that stuff?
So I'm using Arista's two Arista 7050s, QX32s, which is kind of abusing them a bit. So, but they can do with there's different. The Arista platform is quite flexible in that you can kind of shift the way you're using the tcams around so that you can optimize it for layer 2 forwarding or layer 3 or various different options. But
that's very Cisco-ish. You'd expect that from a company that split off from Cisco, right?
Oh, well, yeah. Well, I think they had a different approach to Cisco, but not maybe on the command line.
But Cisco switches have the same thing. You can optimize them for different kinds of forwarding, reboot it, and then it'll switch the TCAM stuff around.
Oh yeah, I think So in the Arista ones, they have this ALPM, which is algorithmic longest prefix matching. So like your typical, like these are Trident 2 based chipsets, Broadcom Trident 2 based switches. And they do about, with ALPM on, you get about 350,000 routes you can load into the box in hardware. So what we typically have is 2 openBSD BGPd route reflectors, which are also multi-hopped to our 2 upstream transit providers. And then they dump in basically anything shorter than /23. No, /22. So anything less than and /31. So there's about, I think that if you calculate that out in the route table, that dumps in about 80,000 routes into your 40 or 50,000 routes into your into the aristas, and then basically we then take all the feeds from our local exchange, INEX, which is fabulous. Like they take about 60 to 80% of our traffic depending on the day. So with them, we take their routes, and that's 80,000 routes off them. So you're well within the range of what the aristas can handle. Converge is pretty good, and they're behaving themselves nicely, and they're working as they said on the tin.
So how many routes do you think you settle on average in those aristas?
On the aristas, I can probably check, but it's in around 120,000, in around that.
That's not too bad.
110 maybe. So like I'm at a third, but I'm kind of trying to be conservative on that, because I have to do a bit of IPv6 stuff I've been kind of putting off. So I want some space on the tcams for that.
Yeah.
And the tcam space on those aristas, it's shared between the ALPM section of the whatever area of the tcams they're using. They're actually shared between IPv4 and IPv6, so I have to be just mindful.
Yeah, I know on the cat switches on some of mine, the 7200 and 6500 series stuff, you can rob Peter to pay Paul, so you can steal from the IPv6 tcam and throw it into your v4 routes. And it's, since v6 is substantially larger, I think for every v6 route that you steal over, you get 2 IPv4 routes. So, so on like Soup 720 3B, you can get like 1 million IPv4 routes, but you get 0 IPv6 routes. Of course, once you get to about 800,000 routes, you're going to exhaust the memory on the box because of, with BGP, there's NLRI, which is all the additional information, like AS pathing and all of that stuff. It's not just routes that you're getting. I'm doing air quotes here. It's not just routes you pull in on BGP. It's all that it's got community strings, or not community strings, but communities, all that stuff that's attached eats memory, right? It eats resources. So it doesn't just come down to how many routes the box can theoretically hold. It's how much NLRI is packed in with that stuff. So I know here, full table for us in the US is about 750-ish thousand routes. So if we peeled off, it's been a long time since I've looked at it, because I've had to do that before on networks where you peel off, the /20 and bigger, so that your route tables shrink, which it makes them converge faster. It doesn't eat as much memory, and route tables are smaller.
Like it has its disadvantages, but like for what we're saying is local exchange traffic, it's great for an eyeball ISP. So if you're what will determine your download traffic really is your advertisements upstream. So that doesn't actually cost, it doesn't cost you anything. But but if you're actually a content provider, then it's actually a little bit more complicated, because you really want to find out who you want, whose prefixes you need to learn, so that you can actually send the upload traffic to them.
For sure.
And that's when it gets interesting. So most of the download traffic that comes in fine, because we're advertising it outbound, and then it's just really about the upload traffic for us. So what we do is we say learn everything down to the /24 from the exchange, and we'll dump that into the, and obviously it'll have a higher local preference as well on the aristas, and then just
so does your local exchange cut through the aristas to get to your route? Because I've always heard that you really should run exchanges through a switch, so you can do like storm control, stuff like that. Is that something you do on yours? So
like for us, like what we're doing is we have the aristas are running like the full BGP with their neighbors on the exchange, and so what we're actually, because when you do eBGP by default, the next hop doesn't change.
Mm-hmm.
So our transit routers actually also use the aristas, but the aristas, the control plane for that is actually handled by openBSD and openBGPd routers. So basically, if you can imagine, because you say, oh, learn from Cogent and learn from GTT, but because the next hop that I learned from them is actually directly connected network on the aristas, when a customer is sending traffic through the arista knows, oh shit, I can just lash that over onto, it doesn't actually, so it's effectively like the layer 3 version of the route reflectors that you have, on an exchange. On an exchange you have a route server, on an internet exchange you have a route server, and everyone else is exchanging traffic, but the route servers are just doing the control plane stuff. They're saying, well, he's reachable via this IP address. So the BGP routers that we have for openBSD, they're literally just saying, transit is via GTT and they're on this IP address, and then when the traffic's actually flowing through one of the client routers to the arista knows, okay, that's directly connected route, and it'll actually, the path is actually switched in hardware by the arista, and it's not actually been done by the by the openBSD box. So you're kind of using the control plane sophistication and nice stuff with openBSD, and then I'm doing the heavy lifting with the aristas, and that seems to be working quite well.
Right. Well, we had a question earlier, and I had my own opinion on this, and I don't want to taint you. I want to see what you think. Jeremy, my favorite Australian hipster, or it's Jeremy. Over here we say Jeremy, like you haven't washed your hands. But he has 2 routers in 2 different data centers, and he's pulling in connections in both. I'm not sure, I can't remember if they're DIA or it's like an exchange or whatever. But he was saying, hey, should in data center B, should I just pass that BGP peer through over to data center 1 and then do all of my peering on one router? Or should I peer on each router in each location? What's your preference in that scenario? I know you can't see a diagram, and that's kind of a loose interpretation, but
I prefer having a layer 3. Like if you have a different POP and you can actually make intelligent routing decisions at a POP, I'd be saying you should have a layer 3 device like a BGP router there as well. For a simple reason that if you have, let's take for example Dublin, London, New York, and you have 3 POPs. There's exchanges at each one of those POPs. It would make sense that you'd have a router locally that could kind of offload traffic to your local exchange there, rather than actually tromboning from Dublin to New York to get to, let's say Google's 8.8.8, which will be actually available pretty much on net at one of the other locations. So for us, if it's likely that you're going to be peering with multiple people there or have lots of clients that would want to just route out locally, it makes absolute sense to have a BGP router at each POP, and allows you then to intelligently, for those particular sites, to kind of say, hey, you know what, learn from Google from this exchange rather than from one of the other ones. And then conversely, at the other POPs, you want to be learning the local, routes, and you can do more intelligent traffic shaping. If you just pull it all back to one data center, those types of stuff, that type of traffic shaping becomes much more difficult, actually impossible in my opinion.
Well, I was thinking too.
Well, then Tom, so then what if you had, instead of Dublin, London, which are obviously, very different routing decisions, what if you had, say, Dublin Equinix and Dublin Interaction? I forgot to try to say that.
Interaction Dublin, yeah.
So then what would you, because 2 POPs in the same town.
Okay, that's different.
And remember, too, that you've got layer 2 between these data centers, right?
Yeah, but I suppose...
You marinate on it. My thought was, if you've got 2 locations, go ahead and BGP peer in both locations. One is you know, if you're peering, you know, one in each location, it's not going to consume as many resources when it's, you know, doing recalculations and stuff like that, right? So it kind of spreads out the load. And two, say you lose a data center in one location, your customers can still get out at the other one, right? But if all your peering happens on one router and you lose that router, well, you're dead in the water. That's kind of, that was my simple thinking there. Don't put all your eggs in one basket if you can help it.
Yeah, no, it makes sense. On the local ones, it's like if you have pretty good bandwidth and you're not worried about, like, you don't have links saturating one pop, you could do it out. But it, like what you're saying, the multiple, having all your eggs in one basket doesn't sound like a great solution. And if you're paying for space in a pop, why not put a, you know, like, you know, the routers, you know, a lot of them now are 1U devices, you know, dare I say, you know, like some of the Arista stuff that I've been seeing, that even on that stuff that's on the grey market is very attractive. Just throw it in there. But I suppose if you're talking about just getting layer 2, like, so a lot of places, you know, they'll say, oh, do you want layer 2 on AMP6 and bring it back? You know, so you get layer 2 circuit from an internet exchange somewhere else, and then you just do all your BGP in one location. That's not a bad option either, you know, but that's because that's saving you on the space at that location.
But you'd still recommend landing on 2 different routers though, right?
Oh, fuck yeah.
Yeah.
Yeah, diversify as much as you can, even if, because, right, like sometimes you can just get a circuit over to a data center, so you don't have to pay, what, $1,200 a month for space and all that stuff. You're just paying, you know, the cross connect fee or whatever. Maybe not even a cross connect fee, just the circuit fee. So that could save you a ton, and especially if you're still small and you're growing. I mean, this can be a solid option. So pivoting, while we're talking about hardware and technologies.
Well, hold on. Just real quick, since we're on Arista a bit, I just want to get in there. If anybody has Arista switch recommendations, I'm looking, I guess the 7050 series, which is pretty common, does not have the feature I'm looking for.
What's the feature?
Is SNMP telling me, like, interface counters per VLAN per port, like MikroTik does, or Juniper does, in that you can tell how much traffic is on every VLAN on every port.
Right. So, like, it's a trunk port. All the VLANs that are running across, SNMP will tell you on each individual interface how much is moving through that VLAN, right?
Right, yeah, it does. So I've heard Arista can do it, but apparently not the 7050s. So which ones can't?
Well, do you have the newest code on them? Maybe it's just a software thing.
Well, you know, I haven't bought any. It's just hearing from the internet saying it won't do it.
All right.
So,
Gotcha.
No, like, because I remember you were asking. I said, no, I'll have a quick look, and, you know, it's doing an S&P walking, and I went,
you know what you need to do, Mike, is you just need to get a...
Just buy them all?
No, just get an Arista vendor and, like, get a sales engineer to answer your questions.
Well, yeah, but they're going to want something new, and I don't want to buy something new. I want to buy something off of eBay.
All right. Well, you could...
for like $1,000.
You know what? With that comment there, I can just see Arista running out the door saying, lads, get on this. Mike Hammond needs to buy stuff.
Oh, Lord. All right.
Let me ask you something. Could you spin up an Arista in GNS3 and test that?
See, well, I think it's hardware platform dependent.
It's hardware related. Like, you're looking at something deep in the Broadcom chipset. And like if you think about what they're doing, it's kind of complex. Like, for us, it was, you have an SVI interface, or you have that's one way of doing it, or you have a lag, and then you have a trunk, and then you're looking at an individual VLAN in that trunk, and you want to meter them all individually. And, you know, it's amazing that they do it so quickly on the hardware they have, with the power draw they have, even on old kit like that on the 7050s. But they don't do that granular counting that Mike Hammett was looking at, you know, or looking for. But Mike, if I work it out, I'll let you know. Or if there's a workaround.
Because Juniper does it, and I'd rather buy Arista than Juniper. Nothing against Juniper, just I like being able to, it just...
You like cheaper stuff. Just say it.
Arista isn't cheap.
No, Arista's
but it's just
cheaper than Juniper.
I don't know if it is. It's different to Juniper. I think Juniper is pretty good value offering as well, and some of their newer routers are very, 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 very sexy. But I just think Arista is just fabulous. I love the actual OS. Like I had an issue with ARP on an Arista where the timeout value for ARP is it's, if you're once it's in your ARP cache, it's there, but then when it's failed, so let's say one of the problems you have on particularly on IPv4 networks where you try to you get an allocation from RIPE and you just allocate that as a layer 2, or sorry, as the full allocation is effectively your access LAN for your subscribers. Okay, so you have like a /22 network. You literally, if you get that from RIPE, you advertise. You don't try and carve it up. You don't want to lose IPv4 space. And one of the issues you have with that is someone pinging inbound, right? So you're pinging inbound. So you do it. So the RFC for all this type of stuff is, okay, well, let's find the MAC address of this IP that we want to ping on this access LAN, right? And so you go ping. So you do an ARP request. And then if that fails, then there's a timeout, right? But by default in the Aristas, it was 1 second. So if you were running smoke ping against a client, effectively you could lead to creating like a lot of ARP requests.
Right. So say there's a /24 of hosts that don't exist, and people are scanning it constantly.
Exactly.
Every
You're
second.
creating a whole load of ARP traffic.
Yeah.
And
I think MikroTik does the same thing. If you look at their
MikroTik does, and usually MikroTik behaves itself. To be fair, I'm not
yeah, everybody does it.
But because it's the RC is basically like send an ARP request, wait for a response. If you don't get a response, you don't send the packet, you drop the packet. That's why you get these request timed out, and then you get a few destination host unreachable. That's the router saying, I got no ARP response, I'm dropping the packet because the destination host is unreachable. But now MikroTik does have some nice funny bugs, and I have seen where it just creates all balls MAC address and floods the entire network with these.
Yeah, and when you say flood, that's the right word, right? An ARP address goes to every host on the layer 2, so it pumps out every port on the layer 2 segment, right?
Exactly.
It blasts it across that whole layer 2 switching network all the way as far as it can.
And then when you have a unicast IP with what was originally a broadcast MAC, it doesn't bode well for a network. Trust me on that one. So, and it's one of the things that your layer 2 filter should be blocking that type of invalid traffic. But the Aristas had this one where the timeout for a failed ARP lookup was 1 second, which makes sense where, if you have a small LAN, high availability, and you want to be able to say, well, if the MAC address changes or you fail over to do something, I want to be constantly re-asked for it. But on an ISP access LAN, it can be actually quite chatty. And one of the nice things about the Aristas was, of course, there wasn't an ARP command to say, okay, well, there was an ARP timeout value, which was about, I think, 5 minutes. But that was basically saying, I have an ARP request that's working, and if I don't see any traffic for 5 minutes, age it out and redo it again. But there's also an ARP failed timeout, which is basically saying, how long do you wait before resending an ARP to try and see if the host has come back online? And just a second is just too short on an ISP access LAN. So what was nice about the Aristas is you could actually go drop into a bash shell, list the kernel modules associated with that interface, and sure enough, there's actually a timer. It's a timeout value, which I can't remember off the top, but but you could actually edit a current value for that particular interface, which wasn't available on the iOS like CLI that Arista have. But I could drop in, do that, hit enter, job done.
And that's per interface too, right?
Wow. And it was per interface, so you could do it. You could do it really granularly. But what was nice is it gave you access to the kernel parameters that you wouldn't necessarily, I think, get on some other hardware vendors. And it actually saved us, So it was like literally Arista recognized that, okay, if you know what you're at and you need to tweak it up a bit, do it so at your own risk. But for here, it was just an example of it working out nicely. So we just set it to something like 60 seconds. Has its advantages and disadvantages. The disadvantage of setting it to 60 seconds is that if you have a client that reboots and you do a ping request at the wrong time, it's adding another 60 seconds of a downtime where it might be up, but so basically it'll only check every 60 seconds is that host back online. So the host could be back online after 10 seconds, but your outage and your monitoring stats will all say, no, it'll be in blocks of 60 seconds, the outages. Well, or, there can be a situation where at least 60 seconds is added on because of that timeout, if you understand. Mm-hmm. So if the host comes up at, let's say, if you do a ping request at 0 seconds and then at 10 seconds it comes back up, you have a 50-second outage because then it'll only be at 1 minute before the local gateway will actually say, is this host alive? Will I send a packet to this host again?
How'd you land at 60 seconds as your time interval?
I just wanted to reduce the amount of ARP traffic on our network, and
why not? I just meant why not
a factor of 60.
Or...
So it was 1 second. I just in our situation we wanted to eliminate as much ARP traffic as possible. For normal conditions you won't have the issue. It's when you're rebooting a client and maybe you have very tight windows for uptime. That's when you might be a bit more concerned. And to be fair, I think Arista were doing it in a way that was, it made sense to them. I think they were, I think they were saying, look, a second on a high bandwidth network in a data center is, and, a few 100K of ARP traffic is not such a big deal in a data center network.
Yeah, I mean, do you think that's usually where you see Arista stuff? I mean, that's mostly where I see it, is in data center environments, just aggregating tons of servers.
Yeah, no, that's where and being honest, that's where they've been targeting it. I mean, they did a Wi-Fi acquisition there recently, which I thought was interesting. But look, the switches, and even the book Arista Warrior, which is very good on the layer 2 stuff and multi-chassis lag setups, very light on OSPF and the BGP stuff, I have to say, but for the actual setting up of multi-chassis lags, and if you haven't done it before, I actually found it useful because you can read a manual and you see all these settings, and you get, if you read a manual, you see all these settings, and it's like you get setting overload, and you're kind of going, which ones do I need to set all these settings? When really there's probably about 5 or 6 core settings that you really need to know, and the rest are special edge cases that you'll research when the time comes because you need it. So I find that having a book like your man's Gary A. O'Donoghue's book on Arista Warrior was probably the best €17 I spent on eBay,
Yeah, that's one of the problems I have with wikis, is a lot of times it tells you what all the knobs are, but it never says when you should turn the knobs. Yeah. Or common use cases, or this is a basic configuration, everything else is optional, right? These are tweaks after the fact.
Hey, Tom, what was the name of that book? Arista Warrior?
Arista Warrior, yeah. It was very, what in that book, they did say that, look, these switches are designed for data centers. And if you look at them, they all have hot swappable, removable fans. They have multiple levels of redundancy. You can lose 1 or 2 fans and you're still not going to lose the chassis or lose the switch. And in fairness, I'm being generous to myself. I'm calling a 1U device a chassis, but it has 2 power supplies. They're removable. You can, the fans, so it can be reversed, or not in software, but you can buy blue ones or red ones depending.
On how you
and
want
if you're
it,
pretty handy with a screwdriver, you can flip them, yeah. But it's just be careful, because when you flip them, just make sure to mark the colors. But then, to be fair, that they're now with the reverse, and also it can be quite confusing because the fans have a slightly different. There's a chip, or not a chip, but the PCB looks slightly different between. So the hot swap is actually done with a little PCB that goes into a blade, if you know what I mean, for the fan.
like a Atari cartridge.
It's slightly different between the red ones and the blue ones. So if you have all these red ones and then you slap in a blue one, it's not going to work, and it'll actually cause a fault. It'll say, right, because you have fans actively working against each other.
But tell me about the book again. That seems pretty interesting. So does he tell you when to use which setting, or is it?
It's more like if you kind of go like this. Here's multi-chassis lag. Here's how you set one up. And it's literally like 4 pages, and you're setting it up and it works. And like I've tested it, where you're yanking out, a QSFP, a 40 gig QSFP, and you're seeing one ping drop and everything's just back to normal, and it just has made my life a lot easier using that type of kit in the data center, as opposed to cheaper switches and stuff like that. Like I was always one for looking at a vendor spec in terms of forwarding performance, not so much on the, let's say, the higher availability features, and something I regret. But I have to say the multi-chassis lag setup I found quite straightforward, and that book was very helpful because it literally went, if you want to set up a multi-chassis, it's kind of like, setting up your first OSPF network. You kind of know, okay, what do I need to do? Set a router ID is ideal. Add the network that, the IP address network that you need to start, exchanging low packets on, and probably set up your, an interface will appear. You might want to change the password on that, and boom, you've a very basic OSPF network setup. Now the costs and stuff like that you can tweak yourself, and you'll learn them as you go. But it's that type of book. The book was good in that way, and on the layer 2 stuff, he had a good command of even like talking about MSTP versus per VLAN spanning tree, and saying that MSTP, in his opinion, was more scalable because it allowed you that you weren't doing loads of calculations for each different VLANs, is that you just had one VLAN that you were doing your spanning tree calculations on, and that works well in data center as long as you're not pruning VLANs, and that's when you can run into trouble with MSTP, where obviously per VLAN spanning tree wouldn't have that issue as much. So and that was some interesting insights there. They'd also like Aristas have a lot of interesting features, like obviously they have the likes of VRRP, but the VARP, virtual address resolution protocol as well, which is kind of like a layer 2 load balancing type setup as well. It has its uses. We are not using that. We are using the VRRP setup. Again, he goes through it in a few pages, and then after that you can look at the minutiae. You can actually start looking at the manuals and going, well, there's this setting, what does it do? Oh yeah, I'd like to reduce the the amount of time between the VRRP hello messages and stuff like that. Other than that, I'd have to say the multi-chassis lag configuration has been nice.
Right. So this is what I was trying to pivot to earlier: MC lag versus stacking. What's your opinion? So, and this is the impetus. There's been a lot of debate over it recently because MikroTik's saying they're going to implement one or the other, or something like that, and so there's been strong arguments for one versus the other, and people's rationale. I was just curious, where do you land on multi-chassis lag? So multi-chassis lag, right, is where you can do link aggregation between 2 separate switches, right? Which would be like LACP, right? It's the open standard. Yeah. So it's kind of like bonding one interface or rather bonding multiple interfaces to sort of appear as one, but you're actually going to two chassis for redundancy, right? Whereas stacking is take a bunch of switches and they functionally, the management plane acts as if it's one switch, right?
Yeah.
So where
My
do
big
you
question,
land?
yeah.
MC, like all the way. Stacking is not a redundancy. Stacking, regardless of any marketing bullshit that Cisco has come out with, you show me a stack that didn't have a switch fail, that didn't bring down the entire stack, that might have been recoverable once they rebooted one switch or another. You have that case where when you have all these backplanes of switches attached to each other and they're all exchanging messages, and it's fairly mission critical stuff, and if something locks up hard and bad, don't tell me that that's not going to have a bit of contagion. That said, I'm grabbing wood here, the wooden table here, and I'm saying I'm hoping that the multi-chassis lag setup is a lot better. Now it looks like what happens is with the multi-chassis configuration, based on what I've seen of the configuration, I could kind of tell you about it briefly, is you would link the two switches together, obviously, and then you put a VLAN that you designate as a multi-chassis link VLAN. And basically you put an IP on each, so it's a layer 3 type of setup where you say put an IP on one switch, put an IP on the other switch. So they're actually exchanging traffic that way. And it looks like they encapsulate the traffic. So the beautiful thing, the reason why LHCP layer 2 redundancy is very hard. Why? Because you don't know at what point your layer 2 failure is going to be. The only failure you can be certain of is if it's directly attached. But if you have an upstream failure on a lag, or even like adaptive load balance and ALB teaming and stuff like that, if you have a failure beyond the switch, you can black hole traffic. That's why the whole spanning tree stuff was invented and all that type of stuff, and why we all think it's too complicated. And, well, I certainly think it's too complicated and it's hassle and all that. But it solves a very important problem, which is sometimes you need to fail over that link because you don't actually have a path anymore there. The multi-chassis lag gets around that by actually saying, right, if you lose a layer 2 path directly via a switch, or sorry, indirectly via a switch, it can send it down the multi-chassis lag link, encapsulate, de-encapsulate, and put it back out. That's what I think is happening based on just not reading any source code, but actually just reading the config and how it's interacting. And it works quite well.
Yeah. I think, what did Thrift say? He said stacking is technology of convenience, not of redundancy.
Well, you know what? If Andrew Thrift says it, I'm backing it 100%.
Yeah, me too. That's what I'm saying.
I'm curious. Why would you want to use? Why would you stack if the only purpose for stacking management, which, like you said, is convenience, and just doing lagging across switches? What else would a stack give you?
There is one thing. A lot of bandwidth.
Stacking would work great in access, where it doesn't matter if this department goes down, you know, like in an office building, you just plug it, you just stack what it switches, it'd be fine there. Not in a data center, not in a service provider.
Yeah, so stack, when you have a stack, generally it's one. So say you've got a stack of 10 switches. You log into one management interface, and they all just look like line cards on there, right? You can do, in a lot of them, I can't say all of them, but you can do a lag between different switches in the stack. So it's sort of like an MC lag thing. Cisco also, and I'm sure some other vendors do it, they have proprietary stacking cables on the back of these switches that all daisy chain together.
School.
And so if you're using like a PoE stack and switch 1 doesn't have enough power, it can steal power through the stack cable from switch 2.
What?
And and pump it to the ports. Also, some switch vendors will do hardware redundancy, so if the regular power supply fails, it can power the switch through the stack cable. It'll just steal power from the adjacent ones, right? So it's convenience features, right? And there's some interesting stuff in there, but as Tom said, if you have one of those things go sideways on you, 9 times out of 10 it's going to take the whole stack with it.
Yeah. And fine, if you reboot it all, it will come back. But
Because they'll
that's
renegotiate
after
with
a lot of scratching of heads and going, do we actually pull the power on all these boxes? But like, because I remember arguing with I had it with a 3-com switch happen to me back in 2001. It was
3-com, yeah.
2 super stack switches, and it was basically one failed, but it pulled down my entire network of 2 switches. But it was uncomfortable enough for me to remember and be psychologically damaged. And of course, I was talking to a good friend of mine, Justin Donahue, and I remember just chatting to him, and I said, I don't know, I'm skeptical about these stacks, you know, I've been burnt once before with it. And he said, no, man, Cisco, like that may have been 3-com, but Cisco is awesome, it never happened. And then he told me about a fairly big customer he had here. He said, yeah, no, you remember you were talking about the stacks? Yeah, he says, it turns out you might be right. Lost the 3750 on one of them. And they had to yank the power out of all of them. Now, in fairness, the other switch, the culprit switch was dead down, probably wasn't exchanging whatever messages they do across the black plane, so it didn't really participate to break anything anymore. And then everyone kind of went, all right, this is the number of switches in the stack, and they only lost the 48 ports of that particular one. But yeah, no, for me, MC lag, like redundancy, like I don't mind a bit of work. I like performance, and in fairness, sometimes stacking is the only way to get a lot of bandwidth, particularly if you have more than, if you have ports, let's say ports A and B on switch A, doing a lot of traffic between ports 1 and 2 on switch B, and you multiply that out by 10. The only way to get that traffic at line rate is through a stack or a multi-chassis lag with a good uplink switch. Yeah, I think I've talked a lot there. I'm sorry.
No.
Yeah.
So you know what? I thought it was interesting after it was all said and done and the dust settled. Somebody, and it was probably Thrift. It's always Thrift, isn't it? Said, why debate on MC lag versus stacking? Just add both feature sets and let people choose what they want to use, right? So you can either stack or you can MC lag. But obviously his preference was MC lag, I think, as most people were.
But MikroTik is not doing stacking. They're just doing MC lag, which seems to be the winner in data center environment.
Well, the theory is there's going to be like 40 gig ports on some switches that you could slam into each other, and then you could do the stack sort of thing through that. And who is it? I think who make the cheap switches? TP-Link? I think the TP-Links, they had some that you could stack in the same fashion, right? Just put the links together. I've never touched that. And I've used the TP-Links, just not for a really long time, and they were okay back in the day.
No, they've been solid, but I've never used the stacking. They had a virtual stacking feature, which I just thought was management fluff gone mad, and I go, why would you try and virtually stack switches, tie them together, apart from laziness, which is not just a valid reason.
Cisco.
But a stack is compelling on the bandwidth front. Sometimes you have to make that awkward choice where it's like, let's hope a switch doesn't die, and let's just accept that the entire thing is going to go to shit when that happens. We all sign a paper saying we're aware of this, and so it's not like, when they have a blame-storming session, how could this happen? Why wasn't this thought of? No, it was, and we accept the risk. But also in the data center environment, stacking is not such hotness because Greg, you alluded to it there. You've got high bandwidth uplinks and you're effectively doing leaf spine stuff anyway. You're going up to a bigger box and then so you're just pushing it north and then going back down again to another. If you're routing between 2 different hosts on 2 different racks. While stacking, is really great in the wiring closet and stuff like that, and sometimes very useful in that, where you need bandwidth, a lot of bandwidth between different ports and a different switch. So I'm sympathetic, but I'm finding myself disagreeing with Andrew Thrift on this one, and that, particularly for MikroTik, and this is no disrespect to them, they have a lot of features. I would say sometimes too much features, and that's a hard thing because I've been one of the assholes asking them for features, and now I'm saying they have too many features. So
too many features that you didn't want. I get it.
Yeah, and like sorry, SMB.
Yeah.
Okay, moving on.
Yeah.
I'm just going to say, fix your root filters. Okay, moving on. Router OS, get your root filters right. Forget about home NASs. Now, maybe they made millions doing that, and happy days, and I'm delighted for them, kind of. But I'm a little bit upset over the root filters. But no, to be fair, and let's go back to what I was trying to make, the point I was trying to make, without flashing MikroTik over the head. I'd rather them focus on quality implementation of fewer features that we could depend on. And that's in a networking environment, particularly in switching or routing, and particularly at that type of grade, you want the resources put into that type of razor sharp focus. And I don't think it's fair of us to be asking for all these hugely weird and diverse features which are useful in our situation but don't mimic best practice. Yeah. And that's where I'd be kind of saying,
or something that wouldn't apply to 90% of their market base, right? But you know what, that leads me into a really interesting question is, and I think that's a great point, and I think almost every vendor could do that. They could take a lesson there, but how do you determine which features are the most important to focus on? Like, how do you figure out the triage on all that stuff?
Well, to John,
the ones I ask for.
Saying if it's my email address to send them, absolutely priority one. Just
see, that's what everybody's going to say. My problem is the most important problem.
Yeah, but I'm right.
Absolutely, but no, in a realistic manner, if you were going to come up with a system for them to focus on things, I mean, you can't just open it up to the internet and say, all right, everybody vote for what they want. Otherwise, you get a ship vessel named Bodie McBoatface, right? So you can't just open that. But so it's like, how do you get in touch with your customer base in, I guess in a healthy way, where you're not just looking at this one person's requests, and you know what I mean? It's like, how do you get an average across your customer base to figure out, one, what features are most important to them, but then what things are you going to focus on to fix or to improve or to add into? I mean, how do you realistically think somebody should go about doing that? Like, I honestly have no idea how one would do that, especially at scale like they are.
It's hard with the diverse product sets they have.
Yeah. I mean, but they all run the base router OS, right? So.
Yeah, but it's kind of like, how do you focus on they're very different product sets and they're very different focuses. Like a part of it will be like, I slag off them about the server message blocking implementation and some other stuff that they've done that just doesn't make a huge amount of sense to me. But I can understand that if you're trying to flog plastic boxes that are sub $40, you're going to need some features like that to appeal, to compete with others. But in the data center, that's absolutely irrelevant, and in fact an impediment to actually using the product. In the first, not being able to switch that off or disable it is just, you can turn it off in terms that you can disable it, but you can't just disable a package like you can get rid of hotspot by just disabling it. And certainly I think they need to be more surgical about how they isolate different feature sets in their products and how you can disable it. And I think that was one of the issues with the dude in Winbox. Sorry, I slightly digressed there, but for us, if you look at Arista, they focused on data center switching and routing. That's kind of where they focused, and their feature sets are around that. And the question they have to answer, and I don't use MikroTik switches at the moment myself anymore, but is like, what's their target market and who are they going to be used? But multi-chassis lag does make sense, I think. I think it also...
So to the point here, something I heard you say that I think actually is really productive is maybe break down the product into various types, right? So you've got switches, right, that primarily should be used as switches. And you've got routers that should be used as routers, and you've got, I would say maybe kind of Wi-Fi routers, and then, you know, wireless ISP type gear. So if you broke it into those parts, then you could focus on features for those, like for improvement, I guess, right? Instead of trying to look at it as a whole, you could segment it, and then you could look at segments, market segments that are going to use the various things and focus on features that way, huh?
Like, I think sometimes, and it's a flaw, I think, of MakerTik in ways, and don't mean this, I comment on MakerTik because I've been using them for, I suppose, years, and, you know, I've tried to shape it positively in any way I could in the past. But if you're looking at it, sometimes I think they turn on a feature, and I don't know if they're fully behind that feature, and they don't. Sometimes it's not finished, and it's left. Well, that's kind of working, or it works in this scenario, but it won't work in any other else's.
Yeah.
And that has been a source of frustration, where you buy stuff, you have a design based on what the spec says, then you go to do it, and it's like, well, no, that doesn't work because whatever. And it's at the moment that the implementation of that is on ice, but the command is there, the winbox checkbox is there, but it doesn't do what it says in the tin, and it can be a source of frustration. And that's where I'd be saying, if you are razor sharp on the focus, that on finishing the implementation, and perfection is a moving target and all that, but like having an acceptable level of performance on a particular feature, that you know that's the only time you should say, right, that's a feature enabled on our product, or it's listed as a feature that works well on our brochures. And I think that's something that, and look, it's not just MakerTik who do that, like, to be fair.
But you know what, I believe that I think your feelings have merit, like the way you feel about it, because you're a very passionate person. You honestly care about the things you do and the products. You want to get behind them wholeheartedly, right? And it feels like to me you want this thing to be so amazing and be so great, and you see the potential in it. Maybe that's the problem, is that you could see the potential, and sometimes they just don't quite get there, and it just, you know, like super bums you out. And I get that. So I think there's definitely, so I'm not, I see you kind of being very graceful, but I'm just trying to say, I don't want to discount the way you feel about this. I think it's very valid to be passionate about the products that you use.
Oh yeah, no, like it's like you're passionate, but I suppose it's when those features don't work. What I'd like to convey, and which I have in very not diplomatic terms in the past.
that's certainly one way of putting it.
I think, what's that called? The understatement of the century. But no, but genuinely, like, I don't mean to give out to people. I don't mean to make things uncomfortable. I don't mean to, particularly a lot of these guys I consider friends. And genuinely, you know, or at least at some stage they were friends. And it's where you kind of go, but when something breaks down like that, it can cause a serious amount of pain for the partners of the vendor, and it's also the customers of the partners of the vendor, and the customers of the customers of the vendors. There's a whole ecosystem of pain, and sometimes articulating that pain.
I feel your pain.
While it's unpopular, and it's not particularly nice, but being at the center of a firestorm and trying to manage it and kind of go, well, this is meant to do this, but you know, it's pain. So, like, you know, bugs, known issues at least is a heads up. Here be trouble. Lack of that is basically, it's like sending war fighters into battle without adequate intelligence, and they're just going to be cannon fodder. You know, that's the reality of it.
Was it forewarned is forearmed? You're ready for it?
Exactly.
Yeah.
You kind of go, right, we're not going to use that feature because we know we'll work around it. We'll use EIP instead of some aspects of traffic engineering and stuff like that. So there's things that can help reduce pain for partners and stuff like that.
Yeah.
And I suppose, while... So, and look, I hope things change, and I think they are slowly.
Yeah. I mean, I see levels of transparency that we haven't seen before. I mean, you can look at the changelog now. There's a lot of information, and to be honest with you, they're having a lot of conversations with us now that it's bizarre. It's like, who are you people? The level of inside information that they're starting to, offer to people. It's just, it's strange, It's strange in a good way. Yeah. I'm unaccustomed to it. Maybe that's a better way of saying it.
No, but look, it's positive. But look, and it's to be encouraged.
Yeah. I'm optimistic.
It's a good way to be.
There you go.
But in terms of the feature requests and stuff like that, I think listening to people who know what they're talking about is good. I'm not saying I know what I talk about all the time. I'm certain, I can take a beating on that front anytime because, sometimes I'm not absolutely 100% correct. But I do think I get it right more often than not, thankfully. Sure. But I think I think also it's good to listen to people who know other vendors. So Andrew Trift, I think, is a bright shining light in that regard, in that he has a lot of other vendors exposure, and that has been helpful. I think that has been helpful in the past, to my critique.
I could definitely see them having part of their R&D department is ambassadors, people that are out in the field, like Andrew Thrift, and then of course they're going to need an American. If only we could find one of those, maybe an Irish guy. Maybe we could find one of those. People that do use this product a lot that could offer insight on these things. Trusted sources. And honestly, you don't want people that always say yes to you, right? You want people that are going to challenge you. You want people that are going to really speak their mind, and you're very good at that. For sure. So I think there's absolute value in that. And sometimes I don't want to hear what people are telling me, but it's always good to know where your shortcomings are.
No, like the openBSD ones, like if I was to circle back to them, like they have a very different method, I suppose, approach to it, in that they kind of say, we don't support everything. We support what we think is important, and we like to think we do it well, and their approach is not shallow. It's deep, it's thought out, but it also means that getting whiz-bang fast throughput. Like I can safely say the MikroTik is faster in some ways than the openBSD in terms of forwarding performance. But then I can say, well, I know that the openBSD one, if I configure it day one, it'll continue chugging along and doing it at whatever spec it did day one, it'll continue doing that. There is innovation when you're trying to innovate, and they seem to have a rapid product development life cycle and release cycle, and that poses challenges. Like I think sometimes slowing down your releases, which I think they have been slowing down recently, if I'm not mistaken, or maybe it's because I just look at long-term and sometimes stable when I see stable because I haven't selected long-term or bug fix on the channel. But like generally I'm more risk adverse on those type of things because of prior experience. And that's across all vendors, by the way. But like sometimes if you can safely kind of, to people who are interested, and I mean the long-term, the bug fix, long-term / bug fix or current / stable, and then your whatever the product development streams, that's a step in the right direction. The only concern I'd have is I don't think they backport fixes that much. I think it's more that they just move a release from one to the other, if you get what I'm saying. Like, so you can go, the long-term support was 6.42, now it's 6.433. But realistically, 6.43 was the previous, it's not like kind of saying, well, we're going to stay on the 6.42 thing. We're not going to add any features. We're just going to do bug fixes. They don't do that. they just slide the. It looks like they slide the product back. You know, the actual fix. They just say, well, the current stable that we haven't had much complaints, or we fixed all the bugs in that, so we'll push that into long term. But effectively, that when you do that update of your long term, you're not actually on a long term track. All you're doing is you're on a slightly older version of MikroTik root OS that has probably been more tested than others. So the name is a bit misleading, I think, in terms of the methodology that I'm empirically seeing. Now, it could be being very unfair with MikroTik, but the reality is, if you look at the difference between the long-term versions, you know, a jump from 6.42 to 6.43 there's a significant feature change in that. And, you know, that's, you know, they're making compromises, I suppose, sometimes. And like I see it when I have to get up off my ass and do something, like, you know, like doing my own openBSD routers, and you see, maybe that's what MikroTik were running into when they were doing, you know, when you're actually at the cold face of trying to, you know, improve your deployment scripts and improve the usability and supportability of the routers. Now, you know, in fairness, the MikroTik, you know, the user interface, I like it. You know, and that, you know, the openBSD one, there was an uphill learning with that, you know, like learning the way openBSD do things. But the stability I got from that was that there was actually more than enough payback, particularly at the BGP side.
For sure.
So it's a hard one. Like, everyone makes calls and decisions, but I think sometimes there's a gap in their methodology where someone's saying, let's think about security. Like, they don't have a security officer, as far as I know. Chief security. Like, I know Ubiquiti announced one after a series of security issues that they had. And I think if they did, and that person's job should be challenging, you're adding in the dude into base MikroTik, you're not doing it, you're putting a dude agent on every MikroTik router. Well, can that not be a package? Can we disable that? Not like, now I know you can have dude server as a separate package, but like dude agent, well, is that not taking dude commands? Is this not, it's going in on the Winbox protocol? And, you know, there was an issue associated with that then recently enough. And when I saw that feature change, I did feed back to them. I said, guys, maybe, I said it stronger terms, but I said, you know, I don't think it's that wise. I think someone should be looking at this from an attack surface point of view and saying, that's a service. That's something you should be able to turn on or off, or a package. Package better. The cloud stuff should be packaged. Should be like, do I want cloud shit on my router? No, disable it. No, don't see it anymore.
Yeah. I mean, well, I always look at it for every vendor. The fewer things you have on there, the fewer things that can go wrong. So it's going to make my router more stable long term. So let me pivot you while we're talking about.
Well, and then not just every time you want to pivot, I'm going to get something in there.
Pivot means Mike, say something.
Well, you know, time talks for an hour, so I got to get something in. But not just disabled, because someone say, well, you know, I have that on there, but it's not enabled, or like, no, like I just want it not, I want the code not present whatsoever, not just disabled or unconfigured.
I had that before, Mike, and it's an interesting thing you say. Like if we were talking about attention to detail, if you look at it, if you do an export of a router that has packages disabled, the fact that those packages are disabled are not actually exported on the router itself. And that, so when you copy to another router, even though it might be the same model, same version of root OS, but when you do an export and then an import, effectively the packages that you had disabled on the first router won't be reflected on the second router. There's a few things about, like, it's just, I kind of look at it and I kind of go, Jesus, you know, surely there's someone and I know there's smart people, like, you know, Yanis is a very smart guy. Arnis is a very smart guy. I think John can be a smart guy.
Yeah, most of them that we've talked to seem pretty clever. You know what I was thinking about it? The way the old system, I'm assuming, worked was a lot of that stuff was baked in, right? And so it's just maintaining the same piece of code over and over time. And it's probably hard to divorce those things that have been in the, like, been core part of the package for the last 10 years. It's probably hard to rip those out, right? But with the new version 7, they're basically writing this whole thing from scratch, right, from the ground up. So hopefully it's more modular and more like Legos, where you can just start snapping on pieces as we need to. Maybe that functionality is something you could see in the future.
Yeah, no, and I think it's also like we're, like, you know, like I think there's a lot of good things they can do. If they're writing version 7 from the ground up, and, you know, they're applying best practices to it, I think that's obviously very positive and to be welcomed. And in fairness, you know, version 6 methodology for releases has been a lot better than previous releases, but they still have some ways to go. And what I'd be saying is that on your current supported production sets, like, I'll give you an example, just a couple of minor ones, the attention to detail type things.
Make it 30
and
seconds.
This is not being, okay, 30, okay. So bug fix, so, you know, it's set system package update channel set, so it was renamed from bug fix to long term. Yeah. Okay, but now if you're changing the syntax, that was a syntax change to the command. You would, if another vendor would alias that command so that bug fix was long term. But if you take an export from version 6.42 something and then put it on 6.43, it'll go, there is no bug fix channel, you know, as opposed to kind of going, well, because often and this is where it would frustrate me a little bit, sometimes where they would use bad English or inconsistent use of enabled versus disabled. Yeah. They would go, but we don't want to break syntax. And I go, that's fine, but maybe alias it, you know, so, you know, like disable running check, I'd be like, well, can you have that and then maybe you have running check enabled or disabled, you know, that kind of way, so that you start to actually make the references for turning on something or turning off something consistent. But so you alias the old way of doing it and you understand it and it's hidden. It's not no longer shown as a suggestion, but that if someone dumps in a config that's old, they kind of go, oh, you know what it means, you know. And they can do, you know, so they could box a bit more clever on those type of things and that. And I don't think it's that hard. I think they have enough people. And I think with and I'm delighted to see the profit they're making, and I wish them well with it. You know, hire a few more devs to have that attention to detail. Hire a few more people with clout where they can challenge even a director, you know, John or Arnis, where to say, look, we need to get this feature. And you go, yeah, but it has to be done this way to maintain best security practices. And I think that would be a welcome thing, or certainly evidence of that happening would be welcome. And I mean, and I'm not being snide or anything like that in that remark. It's just an honest, my appraisal of some of the recent things, which, you know, I fed back to them privately. Look, I'd like to see more disabling of services, like, you know, and actually have a bit more structured approach to how you're putting features into the operating system.
How you were putting features into the operating system?
Pardon? They're putting. I say putting.
So the Russians are taking over Ireland?
There you go.
I know they're just doing that. They're just over the White House at the moment. Don't worry about it. Boom.
No, the report said no collusion. It's fine.
Allegedly.
So something people got a little bit of feedback from various people, and they said, hey, could you pick a single topic and go really deep on it? Boom. So I was thinking, for the first one, we've been talking about switches like crazy. How about, and this could be enterprise or kind of like an MDU ISP thing, how do you configure edge switches, you know, that you're aggregating user connections in? What are some of the the basic security things. You know, you throw all those.
Protected ports, or port isolation, so that they can only talk to the gateway and vice versa.
So port isolation, that's only switch centric, right? So if it moves up a trunk port to something else, it can communicate with stuff on the same VLANs. But like on a
not necessarily, switch, because if you do it hierarchically, and so some switch vendors support protected ports and trunks. So if let's say you have a switch that's aggregating all these uplinks, right? You can isolate each one of them.
Okay. So if you turn on port isolation on a switch, that basically means this guy talking on VLAN 10 can't talk to anybody else on VLAN 10 on the switch, right?
Yeah, except for maybe the uplink port, whatever is a promiscuous port or a not protected port, or not one that's in a different protected. It can talk to. Yeah, so it depends on the implementation. So on Bridge Horizon and MikroTik, it's basically, you know, anything with the same Bridge Horizon value, it wouldn't be able to talk to. On edge switches, it's anything in the same protected port group, it wouldn't be able to talk to. But all other switch ports, if they were in a different group or not in a group at all, would be on it. So when I say edge switches, I mean the actual ubiquity edge switches. And then in terms of the private VLANs, then it's like basically, you know, you have your private and community VLAN, and then you have your promiscuous VLAN. So your promiscuous ports would be your uplink ports, or, you know, a local DHCP server if it was directly attached.
So private VLANs have community more of a more sophisticated version of port isolation, right?
Exactly. It's more sophisticated, harder to understand.
Yeah.
And, but it's nice for the likes of in data centers as well, for isolating different.
Private VLANs generally span switches, right? Where port isolation is usually kind of a local, just single switch thing, right?
It's a local switch, and it depends on your switch architecture, as you were saying. Like, you know, so the way you were describing it is actually correct, factually correct. If you're talking about, you know, if you were going on a trunk to another switch, and then those were both of those trunk ports were promiscuous ports on each end of that. So if switch A is here, switch B is here. Then because these are both promiscuous ports, then the clients in this one will be able to talk to the clients in that one. But if they had to go up to a top, let's say like an aggregation switch, and they were isolating those, then that problem goes away.
So what's the advantage of port isolation? I mean, what does that gain?
There's a couple of things it sorts out. Stops ARP poisoning. It stops a fucking rake of shit that you just don't want happening.
Man in the middle stuff, right?
Man in the middle, ARP poisoning, denial of service, DHCP. So all the things that, you know, you could try and execute man in the middle or DDoS with, or denial of service with, pretty much go away with port isolation. So you can't do rogue DHCP servers, you can't do ARP poisoning. I'm trying to think of other shit that certainly, even ARP spoofing, all that type of stuff goes away because you don't see the ARP requests that other clients are making. So it's quite an elegant way of sorting out a lot of crap.
All right, so
and then also protects clients from each other. So, you know, you're on a layer 3 network, or you're on your network, and it's like, okay, well, I have this IP address. Well, let me just go down by one and see if I can attack my neighbor. That's cut out. Unauthorized communication. So if you're talking about computer exams or laboratory environments that way, where you don't want unauthorized communications between clients, and that you can only have, or even in, you know, government departments where it's, you know, you want structured communication channels between clients for, you know, transparency and accountability and auditing and all that type of scenario. That all just, that the port isolation really helps. Broadcast storm control.
Yeah, storm control. So what is storm control going to do for you?
It depends. Well, there's 3 different categories generally. So you have your unknown unicast flood storm, which is basically, so switches, if you have a situation where a switch, and it usually happens where your ARP timeout is different to your switch MAC forwarding database timeout. So if you have a client that goes off the air, but the ARP timeout of the local gateway is high, but your forwarding database timeout is low. So you can lose, so let's say the client disconnects, just power loss to the house, and he's downloading a 100 meg UDP stream from Netflix or something like that, right? What can happen there is that because your forwarding database loses that after, let's say, 30 seconds, but you have 5 minutes ARP timeout on your gateway, what will happen is the gateway still thinks he knows where the client is and is pushing unicast traffic into the switch. Switch is going, shit, I don't know this, so, and it floods all ports. And so your switch will try and switch and forward packets,
Yeah.
you know,
I mean,
mapping
that's
MAC
part of the learning
address to
process,
port.
right? If a switch gets a packet that's destined for a MAC address it doesn't know, it's going to flood it out all of ports that it didn't come in on, right? To try and
Exactly.
it's going to find that host. That host will then answer back, and then it adds that to the MAC table, right?
And if it doesn't, it's the thing of last resort in the switch is it just floods out on all ports, which can have catastrophic consequences on a switch network.
Say somebody was being malicious and they just started dumping out tons of packets with rando MAC addresses, right?
Exactly, fill the CAM tables, and that's then the switches usually then fall back to a flooding state anyway, which is also used in some man-in-the-middle attacks. It will slow shit down quite considerably.
So what you're saying is it turns your switch into a hub, right?
Yeah, exactly. You're on fire today.
Woo!
Boom. No, but like it's true. Like and then so what Unicast Storm Control is saying is it's like a QoS queue for this type of crap, and it kind of goes, well, if you're going to do that, just allocate maybe 128 kilobits for that, or or how many packets per second. So usually, depending on the switch vendor, it'll be done in packets per second, and it's very useful on wireless networks as well to have those types of limits in and have them particularly low. It's also important that as you go up the chain, that you let's say if you have a large layer 2 topology, that as you go up higher, where the amount of clients are increased, that you up those values, particularly on core, let's say links between core switches, so that you don't trip those, because you don't want to be cutting down traffic.
So you said unknown unicast. There's also what, broadcast and multicast storm control? Is that the other two?
And then there's broadcast and multicast. So broadcast is self-evident, so it's your ARP request, it's your MAC Winbox, your discovery requests, your neighbor viewer. So anything that's going to FF MAC addresses, or I'm not too sure if it includes the zero, the legacy broadcast address, which is all balls MAC address, all zeros. So that one we typically set lows, like around 128 kilobits, and then the multicast one, that's the joker in the pack. Like, it's useful, but if you want to, let's say, multicast out, like your image in a lab of computers, you don't want the multicast to be restricted to 5 megabits per second. So you just got to watch that one a bit. And also an OSPF. So OSPF updates, you have a fairly big event on it. You definitely don't want to go, do you know what, I'm not going to forward those.
IPv6 uses a lot of multicast as well, right?
It does indeed. So like the neighbor discovery, and like it's how it actually works. So but on the OSPF side of things, you can get a burst of messages that will quite easily exceed. So on OSPF links, multicast storm control it can be a foe rather than a friend. So either set the value very high, or don't set it at all.
Storm control, is that usually on your uplink ports or kind of on your edge ports? Where do you usually set that?
We set it on the edge ports, but it's useful to have it on the uplinks, but just at a higher value on the uplinks.
Just in case.
So because it's to stop contagion. So if you do have a loop or something on one switch, that you're not actually pushing it at line rate up to your upstreams.
Right, so how about ports? Like in Cisco, they call it port security, but it's just MAC address limiting on the edge port. What is that? What does that protect?
Oh yeah, so that's that is very useful, and generally depends on the type of clients you're connecting. So for instance, if you're connecting in, let's say, on like a switch in a MDU, or like for not maybe an MDU, but like multiple business units, you know, where you're doing managed services, you might set it to 8 max per, you know, so that you can have your /29s allocated and they can put their firewalls or whatever the fuck they want directly into that port. But then if it's like just for general end devices, then you know you just have your single MAC address.
Well, what is it? I mean, what is it? How does it protect you? Like what is it? Was it really doing?
Okay, the main protection there was actually an attack that we alluded to earlier, where you're dumping random MAC addresses into your CAM table to flood the CAM table, so that your switch then becomes a hub. So there's a DDoS connotation to it, but also the fact that because it's now a hub, you can use it to conduct a very, very slow man-in-the-middle attack.
You can also, I've seen DHCP starvation, right? You just make a whole bunch of DHCP requests from a bunch of different MAC addresses, and you just eat up the entire scope, and then nobody can pull an IP address anymore, right?
Boom. Yeah, absolutely.
Yeah, so there's a lot of little nasty things that port security can put in there. I think you're saying set it to 8 is a really good idea. I've seen people set it to 2, and then somebody will plug in their laptop and then an IP phone, right? And it piggybacks through, and you know, the IP phone actually has 2 Macs on it, so then you're already at 3, and then stuff just quits working. It's just a huge pain in the butt. So give yourself a little margin.
Yeah, like, you know, like it's sensible, like and it's a lot of access ISPs. I know that the incumbent in Ireland on their access handbook, they'd say, I think it's either 8 or 16 Macs is what they restrict any layer 2, even like, you know, when they give you a layer 2 circuit, you know, they don't want a lot of Macs going into their, you know, because of the impacts on MPLS. If it's an MPLS delivered circuit, or indeed just the simple meat and potatoes CAM tables on their directional forwarding switches, you know.
All right, how about DHCP snooping? What does that do for you?
DHCP snooping, well, it's useful for that's option 82, isn't it?
It can do option 82. It can add it in there.
Yeah, so option 82, there's nice things where you can actually identify which port a DHCP request has come from, which is quite nice. There's also a DHCP guard, I think some people call it, where you can actually, and if Ubiquity actually have it on there. So it's like, do you trust, you know, is this which gateway is what is your trusted DHCP device, and anything else is actually detected and
so you can set it on like edge ports, and they're set as untrusted. Then your trunk port is set as a trusted port, and so anything coming from, so if an untrusted port tries to answer a DHCP request, like it's trying to offer a lease, it'll just drop that. So it effectively shuts down. I mean, it's really just almost like filtering the port that DHCP will reply on. I mean, it's almost the same thing.
Yeah, like you can implement it with MikroTik with bridge filters.
Well, they actually have it where you can. There's a checkbox now in the switching stuff in the bridges.
Oh, really?
And if you're using the CRS 300 series, it actually does it in hardware, which is cool.
Okay, no, that's pretty cool. No, because I haven't used that one, but in terms of the MikroTik bridges, we use the filters. But basically, it's just using the way the DHCP conversation, like where do you take the offers from, and you say only accept offers from this port down, so it stops the whole, rogue offers coming in, you know, and stuff like that. But and actually onto that, when you're talking about filtering, BPD filter, we do that on all edge ports facing clients. So
that doesn't allow BPDUs in?
Doesn't allow BPDUs in, so you don't have people affecting your spanning tree.
So what is a bridge protocol data unit? What is that?
BPDU, it's like an OSPF hello packet for spanning tree.
Yeah.
So it's like a bridge-to-bridge communication, and it allows switches to determine the loop the topology of the network.
You know, it's funny, on a Cisco switch, if you enable BPDU filter on a port, it shuts STP off on that port, so you can get a loop.
Yeah, that is.
You got to be careful in Cisco when you're doing that.
Yeah, no, you have to be. Yeah, you have to be. Like, it's funny. I remember it was actually a friend of mine, and like he taught me a lot about switches and routers. I remember one day he was having a problem. He goes, the fucking Spanish is not working. It must be this MPLS networking. You know, he was just testing it, and I went, and I was looking at it, and I went, BPD filters. I said, don't you need that for Spanish? Like, oh, fuck.
But you know what's funny? In Cisco, they do this layering thing. So you turn on DHCP snooping, and it builds this table called the snooping binding table. I don't know why they couldn't just call it. I don't know. Anyway, so it basically creates a table where it adds all the MAC addresses that are allowed on that port, right? Through the DHCP request process, it sees that. And then you can start layering stuff. So then you can turn on something called dynamic ARP inspection, where it'll...
Oh, very nice. So it'll only allow... Yeah, the ARP.
What's funny, though, is if you don't have snooping on, it'll let you add dynamic ARP inspection, and it'll drop absolutely everything indefinitely on that port, and it won't tell you why. That you actually have to layer those together.
Yeah.
So it's
no,
funny
like
how that works.
the ARP, some of those ARP inspections and stuff, I actually don't habitually turn them on. One, because they're harder to understand, like exactly what you're saying, and two, you know, when you want to manually check something, so there are ones where you say, like what you're saying, the ARP inspection, where you're saying, well, it requested this address, it got this address, or requested an address, it got this address, so I'm tying that MAC to that port, and I'm tying the ARP entry to this IP to that MAC, and that's how it's going to, you know, that's awesome. But then if, you know, you're having problems and you kind of get a tech on site and he's plugging in his laptop and he's going, I'll just change my IP address just to see, well, I'll put it in manually. No, it's not working. There's something else radically wrong here. And you're like, okay.
I've run into problems with dynamic ARP inspection, just like tanking across 4 or 5 switches in like a 20 switch network. And so I usually turn it off. What I sort of found that works better for me is DHCP snooping works, port isolation works. So if you just run one VLAN to that switch for those users and that VLAN doesn't live anywhere else, the port isolation, the snooping, that does everything you need. You don't have to worry about dynamic ARP inspection.
Yeah, and the other useful things is like ACLs, like VLAN ACLs or VLAN maps, I think he call it in the Cisco world. So things like, you know, dropping like various different discovery protocols or like VRRP. That's one thing you got to watch. I remember blocking VRRP hello packets basically, but I blocked it, like I said, right. If you can imagine, you have your gateway at the top of your network, and it's like, okay, there are 2 gateways and they're exchanging VRRP packets. And you're thinking, they are the only people who need to know that those VRRP packets. No, that is not correct. In fact, there is no other way that the clients will actually learn that the switches along between the gateway and all your end clients. The only way they'll learn the MAC address of your VRRP gateway is from those motherfucking packets of frames and those frames. And what happens is, so I remember what was actually happening was we were unicast flooding. The customers were unicast flooding upstream, which wasn't a big deal because most of the traffic goes to, and it was actually kind of half working. But people were saying, it's just really slow, Tom, since you changed over to VR. You know, yeah, no, maybe it shouldn't be. Maybe there's something else. And I was convinced there was something else wrong with a particular part of the network. And I kind of was convinced I fixed it. And then someone else said, no, another part of the network is having an issue. And what happened was I basically said, just ahead of those 2 core routers that were with the gateway assigned with VRRP running, I had a rule saying, right, no VRRP beyond this point, which basically meant there was no opportunity for any of the switches between my clients and those VRRP gateways to actually learn that VRRP gateway MAC address. So what was happening was, okay, the clients were learning the ARP, they were getting the correct ARP entry and all that, but the switches had no fucking idea where this actual VRRP virtual MAC was. And so it was all just unicast flooding all the way up. So it was all being capped at 125 or 128.
We just talked about a lot of stuff. VRRP is virtual router redundancy protocol, and it's a gateway redundancy protocol, right? Where
so
2 routers connect on a layer 2 network, and they communicate together, and they say, hey, one of you is going to be the master, and you're going to advertise the default gateway as this virtual MAC address that floats in between the two, right? If there's failure, the other guy takes over. And so they have to actually tell the client, hey, I'm the one that's got the virtual MAC address, and here's the MAC. You're right, they're going to answer those ARP requests and give them that virtual MAC. And you're saying you were basically filtering that out, so they just had to flood
I was filtering that out, and what I was worried about was some a-hole at the bottom of my network injecting VRRP, kind of going, hey, I'm the master, and here's my thing.
Yeah, because you can have more than just one participant in VRRP, right?
Yeah, you can have up to 256 routers, or maybe 255 VRRP slaves. I doubt it's recommended. I can't find a use case, although I'm sure Mike will troll me now and go, well, actually, there is this use case, but I'm
sure Thrift could educate us.
But 250, like, that's really like a sense of, that's a belts and braces and braces and braces and braces type.
Sounds like a hell of a network to troubleshoot.
But being honest, but for that one was a big gotcha.
How did you actually troubleshoot it to figure it out? What was the process? Do you even remember?
Process was, I started, first you're kind of going, right, I'm pinging, okay, that's working. I checked the ARP entry and I'm going, right, they're learning the VRP, the ARP is there, it's fine. It's pinging, but there's a bit of loss there. There's quite a bit of loss. What the fuck is that? No, it's just kind of going, right, maybe it's just... So I said, right, okay, let's just see. And then I was thinking, okay, maybe it's just there's some link failing over and back quite frequently. There's some flapping on a port. So I was logging into the switches along the path. And I was going, okay. And I was saying, okay. And what I kept doing was just saying, show the forwarding database. So you see the MAC addresses and where the MAC addresses and which ports the MAC addresses are being learnt on, just to track it. So I was tracking and I was just like going, okay, it's going to fail over, so there's some rapid flapping, and of course I could see the packet loss happen, and there was no change on any of the switches where I just kept refreshing the MAC address to port binding, or the forwarding database. I was going, and then anyway, so I was looking up, and then I realised, I said, okay, the client's MAC address has been learned throughout. That's not failing over. And I said, what about the VRP? So on the core router, there was no change there, or the core switches. I could see that they were working fine. There was two of them in a multitask lag. And then the next two switches down, I was like, no entry for the MAC address. I was going, what the fuck? I'm going, this is strange. So then I did a packet capture for about a couple of minutes on it. And I said, surely there's traffic coming from this VRRP MAC address that's being learnt on the network, because that's how a switch learns it. And I looked at it and I said, no, okay, exclude all the VRRP frames. We know that they haven't, but surely there's something else. I was like, no, okay, there's not. Okay, that's something. I think I know what the problem is here. Disable that filter for and then suddenly shit just goes back to normal. So it's just one of those things. You're kind of moving to VRRP. You say, I'm going to protect the network from VRRP, but I didn't protect the network from me and my assumptions.
That's right. So the air's not safe to breathe, so you put a plastic bag on your head. That's what you're telling me.
Yeah, that's pretty much it. Yeah, I like chalk it down. So that one was an interesting. Like, it's nice, and it also shows you that look at packet captures. There is lessons to be learned in packet captures. I saw a T-shirt. It was like PCAPs or didn't happen, and I think it's. I learned about openVPN encapsulation issues, and what I understood as the encapsulation overhead was quite flawed, but it was only when I was testing an increment in MTUs by 1 that I realized, well, it's because they have a block cipher and they use 32, they had a block that every 32 bytes, they actually allocate 32 bytes extra for encapsulation overhead, once you cross that boundary. So, you know, you're kind of going, oh, it's 15 bytes encapsulation overhead, and that's what you think it is. But then the next time you increment by one, it's still 15 bytes overhead. You're like, what the fuck's going on? And then you realize, actually what's happening is, so it was just an interesting problem we were having where we were getting a lot of IP fragmentation, which is basically where, which is horrible and it's evil. And I don't know why it was invented, because it fucking doesn't work half the time. But it's basically where if a packet is too big to cross a particular MTU, that they break it up, and they send the original packet as it was, and then they adjust, as far as I know, they adjust the IP header to say if there's fragments, and then they send an IP fragment packet alongside it or after it. And the problem is that IP fragment is actually a completely different protocol. It's not like, my understanding of it stupidly was that, they break up the packet, they use the same header thing, and they just say, it's one, you know, they basically say, there's this the first fragment of, and the second one's going to be here, you know. But what was actually, it's a completely different protocol. And there was an interesting article on Cloudflare. We're talking about how IP fragments are bad and that you should try and cut down your sizes at application level, which if you ever look at an OpenVPN manual, it says, oh no, let the kernel and let your OS do the fragmentation at IP level. It'll do a better job of it. But what Cloudflare were saying is that our load balancers and all this type of stuff look at the headers and are trying to keep traffic and load balance LSCP packets based on their IP headers, you know, like the layer 3 and layer 4 hashing. And these IP ones, so what would happen was, ideally what you want is all packets in a conversation pretty much having the same path throughout the conversation. But IP packets, IP fragments are not the same. They can't be classed. They're not classed as the same as the original packets in that conversation. And they could go a separate path. You can have packet ordering issues. Not only that, but NAT routers and 4G networks just absolutely love IP fragments and love breaking them. Hey, Soph. How are you? This is my daughter.
Oh my goodness.
Sophie, wave.
The brains of the operation.
Yeah.
Hello.
How are you? I think I may have to. This is Greg. Say hi to Greg. She's a bit tired.
Oh, fair enough.
It's 2:08 in the morning here. I may actually have to
All right.
put this little one to bed.
Well, let's stick a fork in it. Let's go ahead and shut it down. I think we've done enough. Tom.
I got it. I'll see you later, lads. Peace out. I might be down later. I'll just mute the mic and I'll be back.
All
right. Do you want to stay? Okay, I'm just going to mute the mic and let Mike talk, okay?
All right, Mikey. If people are going to get a hold of you on the internet, how would you have them go about that?
Go to patreon.com/TheBrothersWISP.
Okay. DM you?
Yeah, or just post in general and someone else will answer.
All right. Anything you say on Facebook.com/TheBrothersWISP, that's Mikey. So that's also, I don't know, probably not as good a resource. Everybody's super reactive on Slack, so that's probably the best way to get a hold of anybody.
And on our Twitter now as well, and our Instagram. I'm on
the Democratic Convention website.
I'm with you there.
Website.
Actually, I think that was the Russians.
Mike. Guys, I gotta run. I gotta pick up my wife and kid.
Right. If anybody's gonna get a hold of you, Dave, how do they go about that?
Just send me an email or get me into the Slack channel. DM me in the Slack channel. Otherwise, my email address is david@pennytone.com. By the way, guys, it's great seeing you. Great seeing you, Tom. I'm glad
Great seeing you guys.
Glad you spoke a lot. I had no idea you were that well versed in a lot of the switching stuff, and as well as the routing stuff too. But it's nice to hear you talk.
That. It's just you. If you make.
Well, he may not be. He just likes to talk.
I do like to talk. Yeah, no.
Well, you had a lot of good things to say, and I'm glad you did. I learned a lot from you. And
okay,
that's
cool.
To be sure.
Well, it was great to talk to you. and really enjoyed it. Oh, one last thing we didn't talk about, but Greg, was it's just VLAN maps to stop like nuisance traffic, like LACP and stuff like that on the access ports as well.
Okay.
All that kind of crap. Anyway, I gotta go.
Tom, if people are going to find you on the internet, how do they do it? Quick.
Slack, the Brothers Wisp. I'm off Facebook. I'm declouded myself.
Oh, good man.
I saw that. I saw that you weren't there anymore.
Yeah, no, I just kind of went, why am I telling everyone my business? I should just do this through the Brothers Wisp channel instead.
So then you're going to show up now?
When am I going to show up?
Yeah, so...
I'll probably go to the... I'll try and get to the... I'm going to BSDCan next month. It's in Ottawa around the middle of May. And if you want to learn about BSD and talk to serious experts who know networking, like programming wise, and why can't we do this, they'll explain to you all the difficulties of doing it. And I'm going to hopefully upload some interviews I did with a couple of free BSD guys who were getting like 90 gigs through VXLANs from guests on a free BSD Beehive box to a guest on another free BSD Beehive box over 100 gig NIC. Some cool stuff like that. Basically, they're saying, and that's not with FastPath, not with Nmap. That's literally kernel forwarding. So it's pretty awesome, like with encapsulations and stuff like that. So, but yeah, if you want to talk to people like that at that level, they're awesome to do. And I'm just hoping that their genius just rubs off me, at least by association.
If you happen to, on your trip, come down to your trip to North America, if you happen to come down to the States, maybe say to Florida or something like that, maybe we could organize some kind of a meetup. That would be kind of cool to see you, just in case. Just let me know. Slide in my DMs. Let me know.
I will do that. And come here. Look, guys, thanks for having me again, and thanks for always ringing me on a Saturday. It's just usually I've been working away, but I'm on holidays at the moment.
All right, man. We'll enjoy it. Bye, guy.
Have a good one, and peace out. And say hi to Sophie. She's my best friend.
It's good to see you have friends.
Be good. Bye.
All right, so if you guys want to get a hold of me, I'm Greg at gregsoul.com. That's my email address, gregsoul.com. I've actually started blogging again a little bit here. I'm trying to do the brain dump thing, which is generally where most of that content comes from. Again, join us on our Slack, man. Great conversations. One last thing, the mom, I had such a great time meeting all of you guys in person. You guys need to put your pictures by your name in Slack so that I actually can recognize your faces when I meet you. It's super weird to have people walk up. You know what I found out is people listen to us, they hear us, they get a feel for our personalities, and then when they meet us, it's like they already know us, but they forget that they are complete strangers to us. So put your face on there. It's going to help me a lot. I'm better with faces than I am with names. Again, patreon.com/TheBrothersWISP.
My Slack picture is me holding a chainsaw.
So that's not helping anybody. But you got your face on here, and I know your face because I see it all the time. We haven't done 5 tips in a long time. People say they like those, so you guys keep coming at me with that. Fight me. What else? We've had requests for interviews of people international or people that just to get on and tell me about your network, tell me why you built it the way you did, lessons learned, stuff like that. So interested in any of you guys coming at us, let us know. Again, thanks for listening. This was a dramatically long one. This was like 2 hours. So if you made it all the way in, congratulations.
On that note, I just saw during the cast somebody commented on one of our previous videos with pickles. I don't remember which video it was. I remember it was really long. We said, if you made it to the end, say pickles.
That's hilarious.
And somebody just did tonight.
All right. And for Ty, try it out. You want to try it? Get a lease and a key, brother. Let's see. For Nick Ariano, I'll give him Wheel Snipe Sally, boys. There you go. All right, so everybody else, if you don't get the reference, that's not my problem. If you do, you're the bomb. See you guys next time.
I don't.
Start searching, shooting up the web in neighborhoods, net surfing. We got horrible jokes, we're loud and annoying, but we're informative facts, we're not disappointing. Just give us a listen, cause fun is the mission. I'm telling you, you don't know what you are missing. Ideas and some good comedy given. If you missed the show already, don't worry, you're forgiven.